Have you ever wondered what would happen if we could produce energy without generating waste, carbon dioxide, methane, radioactive materials, or rare fuels? This is exactly what fusion energy promises to deliver. Although it might sound like a pipe dream, it is a possibility that has been pursued for the past 80 years. But something changed recently. On December 5, 2022, the Lawrence Livermore National Laboratory in California achieved something that was considered impossible by many experts. They produced more energy than they put in using fusion energy. This is a remarkable achievement and cause for celebration, but all is not as it seems. In this episode, we will explore fusion energy, its potential, and the challenges that it presents. Let's start with the basics. Since its use in the atomic bomb in the 1940s, scientists have been exploring the possibility of fusion energy. Unlike traditional nuclear energy, which involves splitting atoms apart to create energy, fusion energy involves fusing atoms together to produce energy. The byproduct of this process is helium and some neutrons, which are harmless. In fact, a fusion reactor would produce no long-term radiation or radioactive waste. Another advantage of fusion energy is that it has very little environmental impact, and the fuel is abundant. In essence, wherever there's water, there's fuel for a fusion reactor. However, it could actually be a big problem because obtaining fuel from seawater is not an easy task. We will discuss this further in the video when we talk about the challenges of fusion power. Furthermore, fusion energy has a safety advantage over traditional nuclear energy. Meltdowns are impossible because it requires energy to keep the fusion reaction going. If there's any kind of problem, the reaction stops within seconds because there's no energy to keep it going. But the most significant advantage of fusion energy is that it creates 4 million times more unit energy than burning coal or gas, and 4 times as much energy as the more dangerous nuclear fission used in traditional power stations. However, you might be wondering if nuclear energy leads to radioactive disasters and atomic bombs. The answer is yes, but only in the case of nuclear fission, which involves splitting atoms apart. Fusion, on the other hand, involves fusing atoms together, and there's very little harmful radiation involved. For those who know a bit more about atomic technology, you might be thinking about hydrogen bombs. While fusion is a part of it, the fusion part is only there to aid the fission part. The fusion part involves uranium, which is still a very dangerous material. Interestingly, fusion is entirely natural. The sun is a giant fusion reactor in the sky. If we could do this on Earth and control the energy released, it would be the most significant change in human history. It's a difficult feat, but the benefits are worth the effort. Scientists around the world are working to make it happen. So how does fusion work exactly? Under ordinary circumstances, atomic nuclei carry a positive electrical charge, which repels other nuclei. However, when heated to temperatures of millions of degrees, the electrons leave the nuclei, and the nuclei become a superheated soup called plasma. In this state, the nuclei vibrate around like crazy, and under the right conditions, they collide and fuse together, releasing energy in the process. In a recent experiment, the American team at the National Ignition Facility achieved fusion ignition in the laboratory, a feat that has been a long time coming. The journey to this discovery was not an easy one. In fact, the Americans had only achieved 10% of the conditions needed for ignition by 2012. The facility was then converted and partially used for weapons research. This was disappointing for the Americans, as even as far back as 1997, the Europeans had already achieved 67% of ignition conditions using a more widely accepted method. But the Americans persisted, and by 2021, they had achieved 70% of the way there. In late 2022, they made some improvements to the fuel target design and achieved 154% of ignition conditions in one fell swoop. This means they got more energy out of the reaction than they put in. On December 5, 2022, the American team turned on one of the most powerful lasers in the world. They stood by as 192 laser beams smashed into a tiny fuel pellet, with 2 megajoules of energy going in and 3 megajoules coming out. America had beaten the Europeans to this moment, and Energy Secretary Jennifer Granholm could relish in this fact, stating, "This is what it looks like for America to take the lead, and we're just getting started." The scientific community was ecstatic about the achievement. Carolyn Currans, a plasma physicist at the University of Michigan, stated that the result clearly surpasses that mark, leaving no question that they have achieved fusion ignition in the laboratory. Tanny Ma, who leads the lab's laser fusion research initiatives, got the call while waiting for a plane and burst into tears. She was overwhelmed with joy, jumping up and down and shaking. But while this discovery is undoubtedly a significant breakthrough, there is still a lot of work to be done to make fusion a viable source of abundant clean energy. There is a vast amount of engineering optimization needed to make this discovery practical. The National Ignition Facility is just a research laboratory, and the technology is not intended to produce power. Designing an actual whole fusion reactor to harness this new approach will be a massive engineering challenge. In news publications, it's widely stated that the lab produced 1.5 times as much energy than was used to cause the reaction by the lasers. But this measurement only accounts for the energy in a very narrow way, considering only the actual laser energy hitting the fuel target. If this method is to be feasible for the energy grid, many other factors need to be taken into account. Are you curious about the latest developments in the world of nuclear fusion? Well, here's a fascinating fact. The 1% richest people on Earth own more wealth than the poorest 50%. But let's talk about something even more interesting. Did you know that scientists are on the brink of achieving a breakthrough in nuclear fusion technology that could transform our energy landscape? At the University of California, plasma physicist Troy Carter has been working on improving the National Ignition Facility's laser-based fusion method. The facility has been using outdated laser technology from the 1980s, with lasers that are only 1% efficient in turning electricity into laser light. By using modern, 20% efficient lasers and targeting the hydrogen fuel more effectively, there could be a substantial increase in energy output. However, while laser-based fusion is a promising approach, there's another method that's gaining ground: magnetic confinement fusion. This method uses electromagnets, microwaves, and particle beams to heat hydrogen gas and turn it into plasma, which is then squeezed by superconducting magnets in a donut-shaped ring. When the atoms in the plasma are hot enough and close enough together, fusion occurs, releasing a large amount of energy. Until recently, magnetic confinement fusion was the widely accepted method for achieving fusion ignition. But now, there's a third method that's generating excitement among nuclear physicists: post-compression fusion. This approach, used by Trenta Helian's 6th-generation nuclear fusion generator, uses a novel approach that forms 2 mirrored rings of plasma on either end of a reactor. These rings are then fired at each other, sequentially activating powerful magnets to squeeze and compress the rings towards the center, where they collide, generating an astonishing amount of energy. Watching the bright pink flash of fusion inside the control room of Trenta Helian is an awe-inspiring experience. The delicate symphony of electronics pushing 2 plasma rings into a violent collision and catching that collision in a magnetic trap in the center is a marvel of engineering. The ions trapped within the trap fuse, overcoming one of the universe's strongest forces to create new elements and release an enormous amount of energy. This breakthrough in fusion technology could revolutionize the way we generate energy. With nuclear fusion, we could generate vast amounts of energy cleanly and sustainably, without the harmful byproducts of traditional fossil fuels. While there's still a long way to go, the potential rewards are worth pursuing. Who knows what other exciting developments we'll see in the world of nuclear fusion in the coming years. Thank you for watching. If you found this video informative and valuable, please consider subscribing to my channel and clicking the notification bell to stay updated on future videos. Also, feel free to leave a comment below with your thoughts and questions on the economic trends discussed in this video.